scientists discovered that a single grain of rice contains enough energy to power a 60-watt light bulb for 15 minutes. This is a phenomenon that has been observed in various food items, but the humble umbrella is not one of them. Or is it? It turns out that umbrellas have a surprising connection to the world of food science and cooking chemistry. In this video, we'll delve into the fascinating world of umbrella-related food chemistry. From the science behind bread making to the chemistry of ice cream, we'll explore it all. So, what makes umbrellas so special? The answer lies in their unique combination of materials and design. Umbrellas are typically made from waterproof materials like nylon or polyester, which are resistant to water and wind. Imagine a grain of sand containing an entire library. That's what a single fiber of nylon is like. Each fiber is incredibly strong and lightweight, making it perfect for umbrella canopies. But that's not the only remarkable thing about umbrellas. Did you know that the shape of an umbrella is designed to maximize airflow and minimize wind resistance? It's like a sailboat, but instead of catching wind, it's designed to withstand it. This unique shape is made possible by the umbrella's aerodynamic design, which includes a curved canopy and a sturdy metal or fiberglass frame. But what happens when you combine an umbrella with a food item? The answer might surprise you. It's not as far-fetched as it sounds. In fact, the science behind umbrella-related food chemistry is rooted in the principles of emulsification and viscosity. Emulsification is the process of combining two or more liquids that don't normally mix, like oil and water. Viscosity, on the other hand, refers to the thickness or flowability of a liquid. When you combine these two principles, you get a fascinating world of food chemistry that's both delicious and surprising. For example, have you ever heard of mayonnaise? It's a condiment made from oil, vinegar, and eggs, which are typically mixed together using an umbrella-like process called emulsification. The mixture is then thickened to create a creamy, spreadable texture. But that's not the only example. Ice cream is another food item that relies on umbrella-related food chemistry. The unique shape and design of an ice cream cone allow it to withstand the heat and cold temperatures of the freezer and the mouth. It's like a miniature umbrella, but instead of keeping us dry, it keeps our ice cream frozen and delicious. But what about bread making? The science behind bread making involves the combination of yeast, flour, water, and salt to create a delicious, crispy loaf. The process of mixing and kneading the dough is similar to the way an umbrella is designed to withstand wind and rain.
The ingredients are combined in a way that creates a strong, yet lightweight structure, just like an umbrella.
And then there's the issue of texture. How do we get that perfect crunch on the outside and softness on the inside? It's all about the science of emulsification and viscosity, which is closely related to the design of an umbrella. So, what can we learn from the world of umbrella-related food chemistry? For one, it highlights the importance of creativity and experimentation in the kitchen. It also shows us that even seemingly unrelated concepts, like umbrellas and food, can be connected in fascinating ways. And finally, it reminds us that science is all around us. We just need to look at it from a different perspective. So, the next time you're out in the rain with your trusty umbrella, remember the amazing science behind it. Who knows, you might just discover a new passion for food chemistry and umbrella design. Subscribe to our channel for more fascinating stories and experiments. Like and comment below to let us know what you think is umbrella-related food chemistry, a new area of interest for you. And if you have any questions or topics you'd like to explore, don't hesitate to reach out. We're always here to help. Thanks for watching, and we'll see you in the next video. If you enjoyed this video, subscribe for more food science and cooking chemistry experiments.